Unique Network is a scalable blockchain for composable NFTs with advanced economies. It is the NFT chain built for Polkadot and Kusama. Now, our second genius tonight is the CTO of this highly successful project, Greg Zaitsev, who's in and out researched the high-level technical view of climate impact of NFTs and also a lot more on CO2 emissions. Now, I sure can't wait to hear this aspect of the arena. So welcome, Greg, and we are all ears to all you have to share with us tonight.
Hello. Yes, thanks for inviting me. So this is very sensitive topic for many people because they are, well, we see there is a lot of NFT activity recently, especially within last year, and creating many NFTs. Well, it certainly affects us, but we don't know what do we do with when we mint an NFT. What does it really mean? Let's see what we create, what are upsides and downsides, and how we can make our lives better. I'll start with the mining map. This is Cambridge University data as of March. The champion in mining is the United States. They mine probably 35% of proof of work cryptocurrencies. Surprisingly, the second place is taken by Kazakhstan. That takes 18%. I think it's partially because many Chinese miners have had to escape the country because China banned cryptocurrencies, and the closest country were Russia and US and Kazakhstan. Number 3 is Russia, number 4 is Canada. So these countries use different sources of energy, of course, and not all of them use equally green energy sources. A lot of nuclear power is being used, like you see in the if you average out the power produced by the source, if you weight by the source, you see there's probably about 10 or 11% is produced by nuclear power, which sounds dangerous, but it doesn't produce any CO2. We are good in this. Also, there is a lot of renewable energy used. Mainly, these are hydroelectric stations. Again, Russia, Canada, and USA, all 3 of them use a lot of renewable energy. Then natural gas comes in as so we see the natural gas produces some CO2 footprint. Yes, of course, it's not that much. It's not as much as the coal would produce, but it's still somewhat sensible. We can see some impact here already, and the champion is coal. Mostly Kazakhstan has that input because they use a lot of coal in energy production. So it comes to probably about 27 or something percent of using of footprint comes from coal, and petroleum produces even more CO2, but because we use it so little petroleum to produce energy, we can neglect it in this equation. And the other sources are not so significant. They're negligibly small, so I wouldn't even consider them here because they wouldn't change this picture so much. But let's see Ethereum Ethereum annual consumption. So if you look at this number I have here, it's equal to 107 terawatt hours. So that's how much energy Ethereum consumes every year. Let's see what it means in terms of minting one NFT. If you take an average smart contract, ERC-721, without much additional features, many additional features, without much doing in terms of data or maybe some computation that's related to mining an NFT, just plain creation, it produces probably about 90 kilograms of CO2. Going further, one transfer of Ethereum on Ethereum, one NFT transfer produces about 48 kilograms. That means you can ride an average sedan for about 200 kilometers. That's already, but that's very impressive number. It's actually minting one NFT is more than an average human weight. This is a lot. And this is just produced in one single transaction and in short 15 seconds. Just if you think about it, it's very damaging because there are lots of NFTs. It's only one that produces 90 kilos. For example, I've been to NFT conference in Lisbon in March. They were using NFTs as entry tickets, and collectively, people who visited this conference minted 1,158 NFTs, which was equivalent to 110 metric tons of CO2. And the story doesn't stay here, doesn't stop here, because NFTs keep being transferred. Keep being transferred from, they keep changing hands, which means every transfer still produces about 50 kilos of CO2. Let's distract a little bit. There is an artist. His name is Johnny Lemercier. He's been working. I call it sad story, but it's really it really has a happy end because he ended up using proof of stake networks. But let's see how he came up to this conclusion. He was initially the conventional artist. He was painting his artwork on the physical carrier, on the physical paper or canvas, and he was bringing it to the exhibitions physically, and then he calculated that every time he comes to an exhibition, he needs to buy an airplane ticket, which means he is going to travel that airplane, and that airplane is going to burn the fuel, which produces a lot of CO2. He says, okay, I'm not going to travel anymore. I'm going to use digital NFTs, digital art. And after he made this decision, he spent about 2 years accounting for every piece of energy his studio was using. He was saving energy. He didn't use a lot of light or a lot of electric power. And after he created a bunch of images, he decided to mint an NFT. Guess what happened at this point? He created one NFT, and the next thing he realized, he just burned, or he just neglected the 2 years of energy savings, and he consumed actually more energy than he would consume his whole studio would consume in 2 years. He got really disappointed. But then, yes, like I said, he decided, yes, let's use proof of stake networks. So let me show you what this really means. So what is proof of stake? How is it different from proof of work? Proof of work is a type of consensus for the network that uses hash power to create blocks, like Ethereum or Bitcoin. There's a bunch of them. The biggest problem with proof of work networks is that they need to have a lot of compute power, and they consume a lot of energy because of that. So the proof of stake is different in the sense that in order to author a block, the miner doesn't need to do any work. They actually need to prove that they own something, they have something at stake. If they mine a block and modify it in some malignant way, trying to take advantage of something, they will lose their stake, which means that becomes non-profitable for them. It's they have a negative profit. So this is using the stake here is kind of a proof that the miners wouldn't cheat. So that's why it's called proof of stake. If I own something, I can participate in that consensus. Ethereum 2.0 is close to being released, but unfortunately, it's not that that big of a relief. Yes, of course, it's so much better. So annual consumption for the Ethereum 2.0 is projected to be around 70 gigawatt hours, which is much better than 107 terawatts. It's more than 1,000 times better. But yet still it's a bit inefficient because of the way Ethereum 2.0 is designed. They reduced, in order to improve the decentralization, they reduced the amount that the minimum amount that validator should have at stake, that miner should have at stake, which is equal to 32 ETH. If you have 32 ETH, you can become a miner or validator. But the ideal number of validators in the network is thought of to be sometime in a range of 1 million. Right now, it has around 300,000. Yes, these are very small machines compared to miners or hash ASICs. They consume much less energy, but there has to be 1 million of them. 1 million is a significant number. That's why we come to this still huge number of 70 gigawatt hours. If you recalculate it into NFT mints, it's 45 grams of NFT of CO2, which is equivalent to a few full charges of a smartphone. Not terrible, again, so it's not kilograms or not human weight, but it's still significant. So 45 grams is still a lot. It's the next networks that proof of stake networks that come to mind are Tezos and Polkadot. Why I don't put any other networks here, any other proof of stake, just because they are approximately the same. They produce the same amount of, or they consume the same amount of energy annually. The only difference between Tezos and Polkadot is that they have a little different mechanisms of consensus, and especially when it comes to or consensus, or actually energy consumption per transaction. Like here in Tezos, we will consume just 1 gram of produce 1 gram of CO2, which is equivalent to shooting 1 hour video. Or in Polkadot, there are actually no NFTs on Polkadot, because Polkadot is a relay chain. Relay chain is a chain that will host parachains that actually can produce NFTs or handle NFTs like Unique, but Polkadot itself doesn't. But even if it had NFTs, just recalculating proportionally this number, I would get 500ths of a gram, which is equivalent for breathing 4 short seconds. Which is already much better, of course, but again, it's still not ideal. Let's see how much better we can do. And here I'm going to talk about the Polkadot parachains a little more. See how the parachains and what the parachains are and how they work. In the center of this, there is a relay chain, which is Polkadot or Kusama. And I've seen somebody asking me what's the difference between Polkadot and Kusama. They're very similar, except Kusama goes a little bit ahead of Polkadot, and Kusama is the parity calls it the wild cousin of Polkadot, which basically makes it the experimental network. It still has value. It's not a test net. Kusama costs even more than DOT if you take per unit, not per capitalization. But they are very similar. Yes, and the heart of it is a relay chain that hosts many parachains. The relay chain consists of multiple validators. There's up to 1,000 validators per relay, but only 5 to 10 validators serve 1 parachain, which means if we are a parachain, we consume not the whole. You can blame us for consuming not the whole power of the relay chain, but only 1/10 or even 1/20th fraction of it. Also, the parachain doesn't need to have many nodes. They are called collators. These are nodes that produce parachain blocks. And also, the parachains can have optimization for NFTs. Like Martin mentioned in his previous speech, that Uni has custom NFT palette, and yes, we do have custom NFT palette only because we'd like to be scalable and optimized for NFT transactions. Yes, you can run ERC-721 on Unique or on Moonbeam or any parachain that enables EVM. But it wouldn't be so as optimal as having a custom palette, because custom palette runs in native code. It's written in Rust, and basically it's as close to hardware as possible, to be close to hardware with a blockchain. So it comes to a very lean numbers. This is a logarithmic schedule. I'm sorry, logarithmic scale, where I put the CO2 emission and for transfer transaction in blue and for mint transaction in red. You see here's that number of it's in micrograms, so it's over 10 million micrograms for Ethereum 2.0. That's by order of magnitude better for Tezos and Polkadot. These are probably about the same. Polkadot is a bit better, but just because of the consensus algorithm. And here on the fourth place, there is a Unique or any other parachain that would do the same thing. We produce so little CO2 or consume so little energy that even on logarithmic scale, it turns to be very small bar here. Again, this happens because we see parachains can be very efficient. They can consume only a fraction of energy, and we can optimize for NFT transactions specifically. So if you make a short breath and exhale, you would produce the same amount of energy as if I would making 30 NFTs on Unique. So this is already significant improvement. So we can mint good numbers of NFTs on parachains without concerning that you affect environment. Yeah, it talks about the current technology. Proof of stake is very ancient technology, and it should be improved. It doesn't mean it does anything useful for us. It's just consuming a lot of energy. And yes, currently most of the NFTs are being produced and sold on Ethereum only because Ethereum has the greatest community. If you'd like to verify what I was talking about, please feel free. There are some references, and here's the QR code for my deck and a few links. Let's have some questions if you'd like.
Great. I think this was really nice, Greg. A lot of detailing into the very fundamental aspects of how things work on Polkadot. So yeah, I think guys, chat is open. So if you have any questions for Greg, you can shoot right away. Meanwhile, we have a couple already in, Greg. So this one's first. So now that we are working on saving the environment and making things better, so do you think the governance is going to get easier? Do you think the various economies are going to start accepting Web3 or the crypto environment more easily now that we are also helping make the world a better place?
I certainly hope so. We are working with UN on the climate initiative. I hope this will help as well. But yes, certainly the governments should definitely look into using NFTs only because NFTs have so many great use cases. It's not only art or gaming, it's also or collections. They can be applied anywhere you see some unique stuff.
Absolutely. Nice. Also, Greg, so what differently did Unique Network do with its tech? If you may subtly suggest, like, of course, not giving away your trade secrets, but maybe how different is Unique, or what is its USP as compared to the other top parachains who are offering similar environments?
We don't have any trade secrets. Don't can't disclose any here. We're not much different than other parachains, only that maybe we are trying to place the things we do first and marketing and every other activity second. Right. If we say we've done something, we've done it. We even started our existence with achieving, we're completing five grants for parity, right, which was the second highest record for parity, to give 5 grants to one company. Wow. And I only think we had this success because we were finishing things.
Oh, that's absolutely great. So I think that's about it from us, Greg. So we don't have too many questions. I guess it was really clear from your end. So we'll take off then. And thanks, Greg, for being a part of this.
Thanks again for having me.